Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at Pythagoras Theorem. So Pythagoras was the name of the ancient Greek man who came up with this theorem, and it pertains to right-angled triangles. So we start with a right-angled triangle like this one here. We know it's right-angled because of this symbol. So we call the two shorter sides of the right-angled triangle A and B, and the longest side of the right-angled triangle is called C. So C, the longest side of the triangle, is called its hypotenuse. And the hypotenuse, the longest side of a right-angled triangle, is always opposite or facing the right angle. So A and B refer to the two shorter sides. C is the longest side. So Pythagoras' theorem says that a squared plus b squared equals c squared. It says shorter side squared plus shorter side squared equals the longer side squared, and that works in any right-angled triangle. So we can use this equation here to find the length of an unknown side in a right-angled triangle. As long as we know two of these lengths, we can find the third length. So I can easily rearrange this formula and get c by itself. I just get c equals square root of a squared plus b squared. I can also rearrange this formula and get a equals square root of c squared minus b squared. These are the two formulae you need to know. You use this formula here with the plus in it when you're finding the length of the hypotenuse, i.e. the length of the longest side, and you use this formula here when you're finding the lengths of one of the shorter sides. So plus when you're finding the length of the longest side, minus when you're finding the length of one of the shorter sides. So the kind of question for which we'd use Pythagoras' theorem is down here. So here we have a right-angled triangle. We know because of that symbol. We are given two of the sides of the right-angled triangle, and we're going to find the third. We're going to find what C equals. So C is the longest side, the hypotenuse. I know that because it's facing the right angle. So I'm going to use this formula here. I simply have C equals the square root of a squared plus b squared. Now it doesn't matter here which I call A and which I call B, they're both shorter sides. So you can put this straight in your calculator and you actually get 25. So the length of this side here must be 25. Now if no units like centimeters or meters are written, just write U for units. So C here is 25 units. So let's try this question here. So here we have two sides of a right-angled triangle and we want to find the third. So 18 is facing the right angle, so 18 is the hypotenuse. Here, x is one of the shorter sides. Because I'm finding one of the shorter sides, I need to use this formula here. So I have shorter side, doesn't matter whether I call it A, X, whatever. So that is equal to the square root of 18 squared. This time I'm minus because I'm finding the length of the shorter side. So when you're using this formula, it's really important that C, the hypotenuse, goes first. Otherwise, you'll get an error in your calculator. So if you do this right, you can put it straight in your calculator. And we get the square root of 180. That's the exact answer, and rounded from your calculator you get about 13.42. So when you're doing Pythagoras' theorem, sometimes you'll get a nice whole number as the answer, sometimes you won't. Once again, if no units are written, just write U for units, and then we're done. All right, let's now look at a slightly harder question. So a 5-meter ladder leans against a wall. The base of the ladder is 3 meters from the base of the wall. How far up the wall does the ladder reach? So this would be pretty hard to know what's going on without seeing it. So if you get a worded question like this, first off, draw a diagram. So we have a 5-meter ladder here. It's leaning against some wall. Now we're told that the base of the ladder, so that's this base here, is 3 meters from the base of the wall. Now we can make this a right-angled triangle because it's safe to assume that the wall is 90 degrees perpendicular to the ground. So how far up the wall does the ladder reach? We're looking for this distance here. So I'll just call it A. So we're finding the length of a shorter side. So when we do our formula, we need to minus. It's the square root of 5 squared minus 3 squared, which equals 4. Everything was in meters. So the ladder will reach 4 meters up the wall. All right, let's try this one here. The hypotenuse of a right-angled isosceles triangle is 2 meters. Calculate the length of each of the shorter sides. So again, we are given a worded question. Let's draw a diagram to see what's going on. So a right-angled isosceles triangle looks a bit like this. It actually has 2 equal sides, and the 2 equal sides have to be the shorter sides. The hypotenuse is always longer than the shorter sides. So I'll just call each of these A. Because they're the same length, I can use the same letter. So we're told the hypotenuse here is 2 meters. So unfortunately here we can't skip straight to the formula. The reason is we have 2 unknown sides. So what we're going to do is use Pythagoras' formula that we started with. So Pythagoras' formula, Pythagoras' theorem says shorter side squared plus shorter side squared equals longer side squared. So a squared plus a squared is 2a squared, and 2 squared is just 4. So to solve this equation here, we need to undo what's been done to a. So BIDMAS tells us we raise to the power first before multiplying. We do indices or exponents before multiplying. So a has been squared, then we've multiplied by 2. So multiplying by 2 is the first thing we need to undo. So dividing each side by 2 gives us a squared equals 2. And then the way that we undo squaring is square rooting. What you do to one side of the equation, you must do to the other. So the answer here is a is equal to the square root of 2. And if you put that in your calculator, you get about 1.4 meters. So each of these must be about 1.4 meters, because 1.4 squared plus 1.4 squared approximately equals 2 squared, or 4. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.